Alright, so in the last video we did more rotations and translations. In this one it's still a little bit more on that, but hopefully very interesting stuff. So right now I've turned off, let's see, what have I turned off? I haven't turned off anything. I'm going to turn off the cubes move my object script, because in this tutorial we're going to be pretty much focusing on the camera movement script. What we're going to do is sometimes it's necessary to get a little bit closer to the position of the object in terms of its x, y, and z coordinates. It's kind of rare, and there's a lot of different ways of getting similar results, as I'll show, but doing other things. But basically this is just an example of really the kind of power you have when you just play with the x, y, and z components separately. So let's go ahead and take a look at the camera movement script. So last time we were here, we've got our transform look at and our transform rotate around. We're going to leave the transform look at in there. We're going to go ahead and comment out the rotate around, because we're going to be rotating around, but we're going to be rotating around in a completely different way. We're going to create a new function, and we're going to use this function essentially. It's twofold. We're creating a new function really just to create a new function, so that there's a little bit of exercise there in the fact that you can create as many functions as you want. And then we're going to access the x, y, and z components of our camera separately and have it do something cool. So let's create a function, and I'm going to call this parametric curve. So the general idea behind parametric curves and anything like that, if you're familiar with the math behind it, it's basically just creating like graphing out things where the independent variable is time. So let's go ahead and we're going to access the transform again, and we're going to say transform.position.x, and we're going to add to that essentially we're going to make a helix kind of movement. So the general idea is that if you think of a strand of DNA or something, we're going to be making our camera follow the curve that a strand of DNA has. So it kind of curves around and goes upwards, and we're going to do that right now. So we're going to use the cosine and sine functions to essentially parameterize the x, y, and z components to follow that curve. It's not really important if you're not familiar with this stuff. You can achieve again similar results without this, but it seems like the easiest way to show changing that stuff. So we'll say this, and then we will have it essentially we're going to use time as a parameter, and the cosine and sine functions just return values in between -1 and 1, but in this case it's going to help us form a sort of a circle. So, and then we'll multiply that times, I don't know, 0.4. We're going to hard code it, it doesn't really matter. And we're going to add a radius really quickly so we don't, yeah, that's fine. Okay, then we'll access the z axis, and we will add, and this plus equals, if you haven't seen this before, it basically just means we're taking whatever is currently in our z and we're adding to that. So it's actually shorthand for transform.position.z equals transform.position.z plus something. So say 0.04 times mathf.sine. Mathf is essentially where you access all the different math functions that Unity has for you to use. Notice we're using time here and not delta time. That's just because delta time returns the time since the last update. In this case, because we're parameterizing a curve essentially, we actually want it parameterized in terms of time, and time is essentially since the time since things started. So, and finally, to get our helix moving up and down, we're going to say transform position dot y plus equals we'll say 0.04 times math f dot sine time dot time times 0.4. So now the general idea is you're going to be following this helix, and since this sine function only returns values between -1 and 1, we're going to follow the helix up a little bit, and then we're going to follow the helix down a little bit. All the while, in our update, we have this look at, but now we have to call this function that we've created. So I'll just call it right now, and it's pretty easy. You just type in the name of your function that you created, and it will be called every update. So let's save. Let's take a look at the results. So now you can see the camera is rotating around the cube, and we're doing this by just talking to the x, y, and z components, and it's moving up, and then it goes down, and it's following sort of that helix curve again. So that's a fairly simple, albeit mathy example of things you can do by just talking to the x, y, and z components and using translations to get what you want done. So hopefully that was at least interesting. If you're not familiar with essentially parametric curves and that kind of thing, it doesn't hurt to brush up a little bit on the math, because it does tend to be the case that when you're working with a 3D game, no matter how abstract or abstracted away a lot of the more hardcore, heavy lifting math stuff is, there's always opportunities to use what you know, and this is definitely a good example of that. Though again, this kind of thing could be done, you know, without really having to parameterize it. So, hope you enjoyed that.